So in this question we're going to look at partial fractions where there is a repeated root in the denominator. What does that mean? Well, in this example, express x minus 5, x minus 2 over x plus 3, x minus 1 squared as partial fractions. The repeated root is this x minus 1 squared term in the denominator. Repeated because it's squared. So if we have a partial fraction like this, there's a standard form that we have to turn this into. So let's write this. So x minus 5, x minus 2 over x plus 3, x minus 1 squared. This can be rewritten as a over x plus 3 plus b over x minus 1, that's the repeated root, not squared, plus c over x minus 1 squared. So that's the general form of partial fractions for a repeated root. And we have to work out what a, b and c are. Well, to work out what a, b and c are, what we're going to do is we're going to multiply both sides by the denominator, x plus 3, x minus 1 squared. So we're going to multiply both sides by that. Well, then the left-hand side just gives x minus 5, x minus 2, and the right-hand side gives, well, a over x plus 3 times x plus 3, the x plus 3 cancel out, we get a x minus 1 squared. B, we have an x plus 3 on the top, one of the x minus 1's cancel, so we get b x plus 3, c x minus 1, and c, well, when we multiply that by x plus 3 over x times x plus minus 1 squared, the x minus 1 squared cancels, so we just get c x plus 3. Okay, and this is the form we're going to use to work out what a, b and c are. To find a, b and c, we need to substitute different values of x into this expression. Well, the useful values are the values that turn some of the brackets into 0, specifically the x minus 1 and x plus 3 brackets, which is when they're equal to 0, a lot of the right-hand side will disappear. So what we're going to do, let's say first of all, we're going to try x equals 1. If x is 1, then all the x minus 1 brackets cancel out. So we get a 0 here, we get a 0 here, and if x is 1, this x plus 3 is 4, so we get 4c here. And the left-hand side is 1 minus 5, that's minus 4, times 1 minus 2, that's minus 4 times minus 1, this is 4. So we get 4 equals 4c, obviously c equals 1. Let's do the same then with x equals, now we've put x is minus 3, because then the x plus 3 brackets will turn into 0. So the left-hand side, minus 3 minus 5 is minus 8, and minus 3 minus 2 is minus 5, and that's going to be equal to a times minus 3 minus 1 is minus 4 squared, and then these other things, minus 3 plus 3 turns into 0. So that means that 40 equals 16a, so a equals 2.5. So we've worked out what a and c are. I'll just write them at the top. And c equals 1. We now need to work out what b is. Let's just get rid of some of this work now. Give us space to find b. Now b is a little bit trickier because there's not really a good value of x to choose that will cancel out lots of brackets. Actually, it doesn't really matter what value of x we choose, because now we've worked out a and c, we can work out b with any value of x. So let's just, for ease, let's choose x equals 0. Then the left-hand side here gives 0 minus 5 times 0 minus 2, and that's equal to a times minus 1 squared plus b times 3 times minus 1 plus c times 3. That's 10 equals a times 1 minus 3b plus 3c. Well, we already know that a is 2.5 and c is 1, so let's substitute those in. 10 equals 2.5 minus 3b plus 3, and this simplifies down to 4.5 equals minus 3b, so b equals minus 1.5. So now I'll just write that at the top so we can see it. B is minus 1.5. So we've worked out what a, b and c are. Now all we have to do is just put those in to our original partial fractions to get the final answer. So let's just strip out this working to give us space. So here's the form that we had. We're just going to substitute in. So we had 2.5 over x plus 3 minus 1.5 over x minus 1 plus 1 over x minus 1 squared. So we're sort of done there. We've got this in partial fractions. Usually we don't really like to have decimals and fractions combined. So we could just rewrite this. 2.5 is the same as 5 over 2. And 1.5 is the same as 3 over 2. So that's probably a slightly neater form where we don't have any decimals. And there we go, we've written this as partial fractions.